right, so we are going to start Unit 7, and Unit 7 is going to focus on inequalities, and there's going to really be two parts to Unit 7. So there's going to be a part where we graph inequalities, and then the second half of Unit 7 is when we solve inequalities. All right, and what we hope to do is kind of connect those two items in the middle so you can understand how solving an inequality is related to graphing inequalities and those relationships. All right, so this lesson is going to focus on graphing linear inequalities. All right, so you can look at our standards there, 13.1. I can graphically represent the solution of a linear inequality involving a horizontal vertical line, involving point slope and slope intercept form, and also stand form. So really, what this lesson is going to center on is, can you graph linear inequality of all forms? So vertical lines, horizontal lines, and then all three forms of our other types of lines. So what we first want to do, all right, is kind of build the idea of what this means, all right, in our coordinate plane. So we have a little bit of an opener here for you. So I'm going to go through question 1 with you here to kind of show you how the process works, and then I'm going to have you do some independent work here. So when we look at question 1 here, all right, we have an equation, all right, and we have our line, y equals 3x plus 1, so we can see that our starting point would be 0, 1. We can see that our slope is 3 over 1 here, so there's that line. It's graphed right here. Now notice what the question is here. Which points in the coordinate plane make the equation true? Now, if you look at, and I'm going to maybe shift my camera here so you guys can see here. Let me move. Look at that magic right there. All right. So if you look, we're really going to look at 3 different areas for these opener questions here. 1, all right, is kind of this upper left-hand region here. 2 is kind of this lower right-hand region. And then the third region is actually just the points that are on the line here. And so what we want to know is, when we look at this equation, are the points in this area, or on the line, which one of those will make the equation true? All right, so you just had to pick one point in each particular region. So when we look at region 1 here, all right, I can pick any point I want out here, okay, and I'm just going to pick negative 2, 2. I'm going to pick this point right here. All right, so that's the point I want to see if it makes this equation true. Now, the way this process works, all right, is I just take, this is my x coordinate, and this is my y coordinate, so I just take those and plug it into this equation. So 2 goes in for y, negative 2 goes in for x, and then I just follow order of operations and simplify to see if I get a true or false statement. So notice on the right-hand side, I have to do my multiplication first, so 3 times negative 2 is, all right, negative 6. And then negative 6 plus 1 is negative 5. So I get 2 equals negative 5. Well, notice that is not a true statement. That is false. Now, here's what we want you to understand. That everything in that region is going to behave the same way. So if this point is false, that means everything in this region will also be false. All right, and we'll kind of come back to that in just a moment, okay? Now, do any points in region 2 make the equation true? So once again, I'm just going to pick a point. In this case, I'm going to pick 1, 0 right there. Okay, so 1, 0. All right, so once again, y is 0 and x is 1. So if I plug those into our equation, y is 0, x is 1. All right, and so now, once again, we just follow those order of operations, right? Do my multiplication first. 3 times 1 is 3, and then 3 plus 1 is 4. So I get 0 is equal to 4. All right, so notice that is also false, which means everything in that region will also be false. Now, do any points on the line make the equation true? Well, I'm just going to pick this point right here, 0, 1. Now, once again, you can pick any point on the line, right? So you notice we have 5 clear points marked here, all right? And once again, it doesn't matter which one you pick because they're all going to give you the same result, all right? So I'm going to pick 0, 1. Now, this time, y is 0. All right, and x is 1. So I get 0 equals 3 times 1 plus 1. All right. Oh, I reversed that. So let me do that again. So I get 1 equals 3 times 0 plus 1. All right, I said it correctly, plugged it into the wrong spot. All right, so 3 times 0 is 0. So I get 0 plus 1. And notice this time I get 1 equals 1. All right, and that is true. So what that means is every point on this line will make that equation true. And that's really what that means, right? That's really kind of what's happening here. There's a relationship between x and y. And every point on this line will make that relationship true. Okay, now that's an equation. All right, so what we're going to move into now is an inequality. So here's what I want you to do. All right, notice now we have y is less than 3x plus 1. All right, so 3x plus 1 is still this line right here. All right, and we're trying to find some y values that will be less than that. So what I want you to do now is kind of go through, oops, sorry, didn't mean to hit my camera there, to go through and, once again, just determine if any points in region 1, region 2 are on that line, make that inequality true. So what I want you to do is pause the video, all right, do A, B, and C for question 2, turn it back on, and then we'll go through that together. All right, so I have my work here. Now, once again, your points may not match my points, and that's totally fine. I just went ahead and picked the same points I used from above. So I stayed with negative 2, 2, 1, 0, and 0, 1. Now, your points might be different. That doesn't matter. The results should be the same, and that's kind of what we wanted you to kind of see here. So notice when I take negative 2, 2, and I go through my order of operations here, I get 2 is less than negative 5, which is false. So do the points in region 1 make the inequality true? They do not. All right, when I do 2, 1, notice this time, when I go through my order of operations, I get 1 is less than 7. That is true. So everything in 2 is going to make it true. All right, and then I try 0, 1. Now notice this time I get 1 is less than 1 there. Well, 1 isn't less than 1, so that's also false. So notice the only points that make this inequality true are in region 2 right here. All right. Okay, good. So now here's what I want you to do. Let's look at the next page here. Let's look at the next page here. There are 2 more questions here. There's question 3 and there's question 4. So here's what I want you to do. Once again, I want you to pause the video. All right, I want you to answer questions 3 and question 4 here. So do parts A, B, and C for both. All right, once you're finished with that, okay, unpause the video and we'll go through those and see what else happens. All right, so let's see how you did. All right, so let me pull up my answer key here. All right. Now, once again, for both questions 3 and questions 4, I just continued using the same 3 points. Now, notice this time our inequality is y is greater than 3x plus 1. So notice when I plugged in negative 2, 2, this time I get 2 is greater than negative 5. So any point you picked here, no matter what point you picked, should, if you did your order of operations correctly and you interpreted this, make this inequality true. Notice with 2, 1 here, I get 1 is greater than 7. So everything in region 2 now makes this false. All right, so no matter what point you picked in region 2, you should have gotten a false statement. Notice once again, when I do 0, 1 here, I get 1 is greater than 1, which is also false. So this time, only the points in region 1 make this inequality true. And that should make sense. We have the opposite inequality this time, right? So we get the opposite result of what we had in question 2 here. All right, now for question 4. Notice the only difference in inequalities. We go from y is greater than 3x plus 1 to y is greater than or equal to 3x plus 1. All right, so let's talk about how that changes the answer here. So notice when I plug in negative 2, 2, I get 2 is greater than or equal to negative 5. That is still true. So everything in, all right, region 1 still makes this true just like it did above, right? So both of those regions are true. All right, so let's go to region 2 here. All right, 2, 1. When I plug that in, I get 1 is greater than or equal to 7. That's still false. All right, so it was false up here, and it's false down here. That should make sense because it's still greater than, and it's still greater than here, correct? All right, so that relationship isn't going to change. But here is what does change. Notice this time, when I plug in 0, 1, the point on the line, I get 1 is greater than or equal to 1. That is now true. So notice what we added here by including the bar here. All right, that equal to. What that now means is everything on the line, all of these points, all right, now make that inequality true. So without the equal to, we only get region 1. Once we add that bar and we get greater than or equal to, we get region 1 and the points on the line. Notice region 2 is still false in both cases, all right, because none of those points there will make that true. All right, so when we come down here, so what is the difference in the inequalities for questions 3 and questions 4? Well, once we get the equal to, we get to include, right? So now we get to include the points on the line, right? That's really the difference, and that's what we wanted you to see. All right, okay, so how does this difference affect which points we make the inequality true? All right, it just adds another set of points, right? So we can see that because it's greater than, we get region 1 in, all right, both questions. All right, so that is a very big piece here. Now, how does that show up when we're graphing inequalities? Okay, so hopefully you're getting a feel for what this means, okay? So now, let's look at the next page in your notes here. All right, let me find my page. Here it is. My notes are all over the place here. All right, so let's look at page 3. All right, so now, when we look at page 3 here, all right, okay, now, notice, here is if we just graph a line, right? Y equals 3x plus 1. And we graph that like normal, all right? So our y-intercept is 0, 1. We have a slope of 3 over 1, no big deal. Now, here's where that last question 3 and 4 comes into play. All right, so notice, when we have the bar, the equal to, what we just said is that we get to include the points on the line. All right, so the way we do that when we graph an inequality, all right, is if we have a greater than or less, excuse me, this is less than. When we have a less than or greater than symbol, we graph a dotted line. Okay, we graph a dotted line. So what that tells me is I don't get to include those points, all right, in my solution set. Those will not make that inequality true. Now, when we have less than or equal to or greater than or equal to, we have a solid line. So we graph it just like normal. Okay, there's no difference. And that's telling me that I get to include, right, I get to include all the points on the line. Okay, so that's the first thing that we're going to do. Do we have a solid line? Do we get to include the points on the line in the solution set? Or do we not? So less than or greater than, dotted line. Less than or equal to, greater than or equal to, all right, solid line. Okay, now, how do we represent those solutions? What we do, all right, what we do is we shade the true region. So if I go back to question 3 here, if I go back to this, what we do is we always shade the true region. So I would have shaded all of this upper left right here. All right, same thing down here. I would have shaded all the kind of upper left here. All right, for question 2, all right, notice it was region 2 that was true. It was down here. All right, and I would have shaded all of that region. And that tells me that if I pick any point in the shaded region, it will make that inequality true. All right, so then notice you can see that that's what I have right here, correct? And now notice the only difference in these two inequalities, this is less than or equal to. It's not going to affect the region that we shade. Okay, what it's going to affect is, do we get to include the line? So notice the only difference between these two, all right, inequalities is that this is a dotted line because I do not get to, all right, include the points on the line. This one is a solid line because I get to. Now, because it doesn't matter, every point will give me the same result. Here's what we suggest you do. Use 0, 0. It is the easiest point to test, all right? So always use 0, 0 when you're testing. It's just easy, unless your line goes through 0, 0, and then pick another easy point, 1, 1, 2, 0, something that's really easy for you to calculate, all right? Now, when we look at this, right, so you can see once again, y is greater than or equal to. So notice the shaded region is the same, all right? This is the true side, just like we went through just a second ago. And notice the only difference is this is a dotted line, and this is a solid line, going back to kind of questions 3 and 4. All right, so that's really the idea when we graph, all right, those linear inequalities, right? So we're going to graph the line, all right, using our forms, right? So we should remember how to graph a line. So whether it's in slope-intercept form, point-slope form, standard form, we're going to use that method of graphing, okay, that we always do. And then we're going to decide if it's, do I draw it in as a solid line, dotted line, and then we're going to test 0, 0 to find out where do I shade. Okay, so now, remember, we have our forms of a line, right? So horizontal lines are y equals b. Vertical lines are x equals a. All right, point slope form, y equals m times the quantity x minus x1 plus y1. We have slope intercept form, y equals mx plus b. And then the semester we added standard form here. So these are all the different types of lines, right? This is kind of your prior knowledge that you have to use, all right, when doing this. Okay, so now let's get into, all right, some examples here. All right, so let's go through and do a few of these together. All right, so now, when we look at our first problem here, we have y is less than 6. So notice this is less than. We know whatever line we graph, it is going to be a dotted line. Now, it's also going to be a horizontal line if we go back to our form. So y, all right, equals 6 would have been that line. So that would be kind of right up here if I grab my ruler. Now, instead of drawing a solid line, I'm going to just draw a dashed line. Just like that. All right? So there it is, horizontal, all right, dashed line. Now, once again, 0, 0 is the easiest point to the test, right? Now, notice in this case, I only have a y value. So I only have to plug in 0 for y, and I get 0 is less than 6. Well, 0, 0 is right here, and that gives me a true statement. So what this tells me is that everything in this region is going to be true. Everything above the line, therefore, will be false. So remember, one region will be true, one region will be false. We always shade the true region. So then I'm just going to shade the region right there. And that's it. Okay, let's move to number 2 now. All right, so x is greater than or equal to negative 2. So the first thing is, okay, this is a vertical line. Okay, it's a vertical line. Now, the next thing I know is it's going to be a solid vertical line because I have the bar. All right, so that means we get to include the points on that vertical line. So now I'm going to draw in my vertical line at x equals negative 2. It is now going to be a solid vertical line there. All right, put my arrows on that one. Okay, now once again, all right, the right side is either going to be true or false, or the left side. All right, one side's going to be true, one side's going to be false. So we said 0, 0 is the easiest point to test. Now once again, I only have the x coordinate, so I put 0 in for x. I get 0 is greater than or equal to negative 2. Well, 0 is bigger, is greater than all negative numbers, so that is, in fact, a true statement. So notice 0, 0 is right here, so that means this is the true side. That means this side has to be the false side. And once again, we always shade, right? We always shade the true side, so that means I want to shade over here, which means at any point you pick in the shaded area will make this inequality true. All right, let's try to do a few more examples together here. Okay, so let's look at number 3. Now notice now we're in point slope form. Okay, we're in point slope form. All right, and then I also know I get y is less than or equal to 3 halves times x plus 3 plus 2. All right, so I know it's still going to be a solid line. So I'm going to use the same knowledge as before. So I know my starting point should be negative 3, positive 2. So negative 3, positive 2 is right here. Okay, my slope is 3 halves, so I'm going to go up 3, 1, 2, 3 to the right, 1, 2. Up 1, 2, 3 to the right, 1, 2, get those 3 points there. And then once again, we said this is going to be a solid line. All right, so I'm going to draw my solid line just like this. All right, there we go. All right, so now, all right, here's what we're going to do. All right, once again, I'm going to just take 0, 0 and plug it in. And then you have to go through your order of operations. All right, so if I take 0, 0 and plug that in, I'm going to put 0 in for y. That's going to be less than or equal to 3 halves. And then 0 plus 3 plus 2. All right, so once again, we're going to follow order of operations. So I have to do what's inside those parentheses first. So 0 plus 3 is 3. Then I have to do my multiplication. So 3 halves times 3. All right, is 4.5, so that's 4.5 plus 2. And so I get 0 is less than or equal to 6.5. Well, that is a true statement. So 0, 0 is right here, and that is true. All right, okay, and that means this side is false. So once again, we shade, all right, we always shade the true side. Okay, so that means I'm going to shade all of that. Okay, so let's do 4 and 5 together, and that will be it for this lesson. All right, so once again, y is greater than negative 2 times the quantity x minus 4. So once again, we're in point slope form. All right, it's greater than, so the line I draw this time will be dotted. Okay, will be dotted. Okay, so I'm going to go to my line here. So my starting point would be 4, 0. So that would be right here. Now remember, your slope, when we have a whole number, is always over 1. So it's negative 2 over 1. So I'm going to go down 1, 2 to the right 1, down 1, 2 to the right 1. All right, and then remember, this is going to be a dotted line this time. All right, so when I draw that line in, I'm just going to dot it up, which means we do not get to include, all right, the points on the line as part of our solution set. Now, once again, all right, I'm just going to take 0, 0 and plug it in and simplify. So 0 goes in for y and x. All right, so I do my parentheses first. So 0 minus 4 is negative 4. And then I do negative 2 times negative 4, and I get 0 is greater than positive 8. All right, so notice this time, 0 is greater than 8. That is a false statement. So that means this time 0, 0 is on the false side. Well, if this side is false, that means that this side has to be true. So I'm going to shade up here. All right, one final problem here. Let's look at number 5. All right, okay, slope-intercept form. It's y is less than, so I know it's going to be a dotted line. All right, so my starting point this time would be 0, 6. My slope is negative 1 over 3, so I'm going to go down 1 to the right 3, down 1 to the right 3, just like that. And like I said, it's going to be dotted, so let me draw that in real quick. Whoop, there we go. All right. Okay. Now, once again, just going to take 0, 0, plug it in, all right, and see what that relationship gives me. All right, so now 0 is less than, negative 1/3 times 0 is 0. 0 plus 6 is 6. So notice this time I get 0 is less than 6, which is a true statement. So that means 0, 0 is on the true side. Everything else is false up here, so this would be the side. All right, I shade in. All right, so that wraps it up for our first lesson on linear inequalities. All right, be sure to do your video check-in, and I will see you next time.